All right. Yeah. Hey, RCOS. For any of you guys who don't know, this is our new RCOS logo. It's a clever open source logo designed by Asher. It's got to be open source. I don't have the green one, but I've got the white one. So.
Is there no motto?
Motto?
Like the knowledge is there?
No. Not yet. We have like a motto competition or something. That'd be cool.
Free and open.
Yeah. So my name is Jerry Schneider. Give you a little information about myself for anybody who's new. Computer science student. I'm the vice president of UPE, the CS Honor Society. In 2011, I worked out in California for a satellite company called Skybox Imaging, doing like flight software and stuff like that. And last summer I worked for TripAdvisor on the social team. So I did a lot of like Facebook integration stuff, some web stuff, some database stuff. It was pretty fun. And now onto my project. One of my projects. So one of my projects is Blue Mesh. And it is a mobile ad hoc network between Android phones. I'm not going to explain this too much because a lot of you guys have already seen this presentation like 3 or 4 or 5 times. But if you have any questions about kind of how it works, you guys can ask me after. We can do like a session. You guys can learn about it. It's pretty cool. Basically, we're trying to avoid using servers and stuff like that when we're writing multi-device applications and use like mesh networking to transmit data. Yeah, so that's the gist of what it is. We're not going to have a demo today, just because, yeah, we didn't really prepare anything for this one. But there is more. I have been working on a Chip 8 emulator, which I wrote in JavaScript and some HTML5. It's pretty cool. It runs these, little Chip 8 ROMs that you can find online. They're in public domain, so you don't have to worry about downloading them. It's totally legal. Yeah. So I just want to talk a little bit about writing an emulator today because I didn't really know where to start. So it was I was all over the place at first, but I thought if anybody's interested, I know there's a couple people like Tom and Josh have already started writing their own. So, but I thought I'd go over kind of like the basics of what you need to think about. Basically, you need to implement the memory. So you need to implement like RAM. You need registers, because processors have registers. You need a stack, probably. Some timers, which this is kind of the hardest part, because it's a little bit like asynchronous compared to the rest of the emulator. And you need some way to do some input, so like, some keyboard stuff, and some output, some way to draw the screen. And like that's pretty much it. They're pretty simple. Really the hard part is implementing all those opcodes and making sure they all do the right thing. So this is like a sample of a Chip 8, some Chip 8 program. This is actually from the game Bricks, which is like Breakout. And you can see stuff like the 4th one down, 1, 2, 4, 6. That's like a jump to 2, 4, 6 because the next instruction is executed at 2, 4, 6. So there's a kind of interesting. You see, it goes up by, the instructions are 2 bytes long, so it goes up by 2 each time. I mean, it's not too complicated. So that was this game, and oops. Does anyone want to guess how many bytes it is? Kind of already saw. Yeah, the whole game, that whole Breakout game is only 280 bytes. It's like 140 instructions, but less because some of the sprites are saved in memory too. Those are pretty big compared to the size of an instruction. So this is the total, this is the largest address you can access in Chip 8. You can go from 0 to FFF,
it's really, you know, not that big. So, you know, the maximum amount of instruction you can have is just over 2,000. So it's pretty small, pretty manageable if you guys want to try to write an emulator. You know, it's not too hard. Does anyone want to guess how many bytes true has? Keep in mind, the breakout game had 280 bytes. Anyone? No. It has a lot more. It has like 27,000. So these programs are like pretty small. And I'll demo it for you guys. I don't want to make this completely boring. So this is the, this is the emulator, and is Colin here? No. Colin helped me implement some of this stuff on GitHub. So he did a bunch of preloaded ROMs, so you can just go on and play. You don't have to download them first. So I'll just demonstrate this bricks game. You see it starts up, and just starts executing opcodes. Not too complicated. And I use, like, this whole thing is an HTML5 canvas, which is really easy to use. You guys should check it out. I also added some other stuff that you can do here. You can like pause emulation and step through it one instruction at a time, which is really useful when you're trying to code some Chip 8 games, which you guys are definitely going to do after this, right? Just go back and try it out. I have like a debug mode where you can check out all the values of all of your registers, and then you can also, let's see here. You can also, when you start emulate again, you can see what where you are in memory and what instructions you're executing. So this is pretty useful if you're trying to figure anything out. It goes also if you you don't have to step to get that. So let's just turn that off. And then I also, because black and white is pretty boring, so you can change the colors of this. Some pretty useful features here. But you guys get the idea. And this is all kind of just showing how easy it is. Like, this was all done in a couple weeks. And after this one's completely polished up, we're going to move on and do like maybe an Atari or a Super Nintendo emulator or something like that. Try something a little bit harder. Yeah, that's the gist of this. We have actually a special ROM we want to show you. Give me 1 second to load it. Yep. Always a good idea to open open stuff during presentations. Let's see. Doesn't work, Josh. Let's see here. One more try. There we go. So Josh wrote this in a couple hours earlier today. It's a pretty good game. I win every time. Cool. So also, I just want to point out, this is funny. A lot of the games, they're like super small and simple. So like when you lose, a lot of times they do stuff like this. It's just like a jump instruction to itself. So you just kind of get like, it just CPU hogs and just stops. So yeah, it's a pretty fun thing to like work with. Pretty rudimentary. So yeah, this is just a picture of me winning Breakout, using my time effectively. And that's pretty much it. So I'd like to thank Sean O'Sullivan, who's our funder, in case anybody didn't know. I'd like to thank Morthy and all of you guys for helping out and for being here, doing your projects.
So the good news is Sean O'Sullivan is going to be a trustee this October, starting this October. So it is a good news. So hopefully RCOS will have a better presence in campus.
What was the toughest part of implementing the emulator?
Probably the toughest part of implementing the emulator
was like when you get something wrong, it's a real pain to find what happened. Like I had a few places where I was like trying to set a flag on some of the like addition instructions. You have to set a flag if you like if there's a carry or a borrow, and I was accidentally bit shifting the flag off the end, so it was always 0, and that just takes like a long time to figure out what's wrong because you have to go back and like read all of the assembly and like check all your registers and stuff. But for the most part, it's not like the bulk of the code is fairly easy and straightforward. It's like if you get a good doc, the doc says like this instruction moves this value from this part of memory to the register. It's just like it's pretty easy to implement most of the things. Anyone else?
Can you write an expression evaluated in you write 2 plus 3? Can you write an interpreter for?
You probably could. It's not really geared towards. It doesn't have like a console output. You have to like draw. You have to like specify pixels and stuff. So it's pretty obnoxious to actually have to write. Like Josh wrote that joint RCOS program, and he had to like draw all those letters. So, I mean, it can add 2 plus 3, but printing it to the screen will be the challenging part.
Bytes are encoded in binary, so you have to flip the bits manually, like figure out which bits to flip. So I also didn't have an assembler, which that made it